I'm going to share some directions with you on the work that you're going to do in class on Thursday, the 21st of April, and then continue your work on the 22nd. This is for geometry. Before this video gets started, either myself or the guest teacher on Thursday afternoon and on Friday, we'll make sure that you have, this is going to happen Thursday, we'll make sure that you have line paper and graph paper in your packet. Prepared to do this work. I'm going to go through and just give a few cues and keys, examples and things, some hints to help you get through it. This is going to be due at the end of class on Friday. An option to take it home over the weekend would just result in a late paper. You guys are going to have 2 full class periods to work on this on Friday, 4/22. Make sure that if you're doing any work on your line paper and on your graph paper that it's labeled. There's different parts of this and we're going to walk through it together. The very first topic that you're going to go back and practice, and this is coming out of section 6.2, we talked about angle bisectors. We also talked about perpendicular bisectors in section 6.2. Our focus on this assignment is going to be on angle bisectors. Angle bisectors do exactly what it says. It takes an angle and splits it into half. Bisect means it splits it into 2 equal parts. Some of these are going to be really straightforward. They tell us that the measure of angle SUT is 34 degrees, so this entire angle is 34 degrees. If I'm going to find the measure of angle 1, I need to take 34 and I need to divide it by 2, and that's going to tell me that angle 1 is 17 degrees. Angle 1 would be 17, angle 2 would be 17. In the case of a problem like number 2, you actually are given one of the measures and you've got to deal with that to find the entire measure. You're given one part, you have to find the whole. So just make sure that you're reading carefully about what each question is asking for, and that you're also showing evidence of your thinking. It's just a measure of accountability for your work. Angle bisectors, when we get down here, we start to see some more going on in our drawings. With angle bisectors, if we go back to our notes, angle bisectors meet at what's called an in-center. Point P, that point of concurrency, is the in-center. And what we discovered in section 6.2 is that the in-center of a triangle is equidistant from the sides of the triangle, equidistant from sides. So in this set of problems, you're given something measuring from point P, the in-center. Point P is the in-center in each drawing. From point P to one of the sides, and in this case, we're told that P to T is 3, and we need to find out what P to U is. Well, it's equidistant from P to the sides is equidistant, so P to U would be 3. That one's pretty straightforward. In my looking and planning, I found that it gets a little bit more complicated, like when you go down to problem number 7. In problem number 7, and I'm going to actually go over to my line paper for problem number 7. I'm going to give you a second to get that set up as well. Angle bisectors of triangles. There's 3 different topics, so I don't care if your work is in order. Clearly we're starting this line paper with number 7. I don't care if your work is in order, just make sure that your line paper is organized and then it gets stapled when you go to turn your work in. Angle bisectors of a triangle, got that labeled up, and I'm going to now take a look at number 7 and what we're given. In number 7, we're told that P to Y, the distance from the in-center to the side, is 2. We're also told that H to P, now this is not in-center to side, it's in-center to this angle. H to P is 3. And actually, what we're challenged with is finding out what this little measure H to Y is. So I'm actually looking at, and I'm going to go take this over and put it on my line paper. I'm looking at a little triangle. Y, I know that's going to be a right angle at Y because it sits next to a right angle marking here. And the measure, this would be our P here, this would be our H. When I look at this, they told me P to H was 3, P to Y was 2. I've got a right triangle. So if I'm going to go find this distance H to Y, I have to look at this in terms of the Pythagorean Theorem. A squared plus B squared equals C squared. I have a leg, an A, a missing B. and I have the C for this right triangle. So if I set up my Pythagorean Theorem problem, 2 squared plus b squared equals 3 squared, that's going to be 4 plus b squared equals 9. If I take 4 away from both sides, b squared is equal to 5. And then to finish solving, I take the square root of b squared and I can express that answer as b is square root 5. I'm going to put the answer over here, make a note on line paper. So look for more complicated problems that could involve something like, okay, what I'm dealing with is a right triangle and solving for a missing leg or a hypotenuse. I'm going to go on to the back side of the angle bisector work. These, again, when you start looking at the back, these are going to get a little bit more complex. Once we get down into number 13 through 16, you're going to see that in 13 through 16 we're dealing with algebraic expressions. Angle bisectors, just don't forget that problems like that in 13 are just going to be a matter of setting the measure, what you have for the measure of angle 1 equal to what you have for the measure of angle 2. We have measure of angle 1 is. And then there's some like 15. I'm going to go over to my line paper and I'll work out 15 for you. I'm still on the angle bisectors, just make sure that it's labeled. And what I find is that they're giving me the measure of angle 1 here. So this angle right here is expressed as 7x plus 7. But then they give me the entire angle. VTU is 16x plus 4. So the whole entire angle is this 16x plus 4. And so in order to find out what x is, what we're going to have to do is consider that there's a couple ways you could set this up. I'm just going to think that if this one's 7x plus 7, this one's 7x plus 7. So I'm actually going to set this problem up using the idea that there's 2 of the 7x plus 7 quantities that makes up the entire angle, which is expressed as 16x plus 4. So 2 times the quantity 7x plus 7 is equal to 16x plus 4. And then I'm going to go through the process of solving this equation, and I'm going to distribute my 2. 14x plus 14 equals 16x plus 4. Don't have any other simplifying to do, so I'm going to start the undoing process by taking my 14x out of the left-hand side. 14x equals 2x plus 4. I'm going to subtract 4 from both sides. 10 is equal to 2x. I'm going to divide by 2 and finish by finding that x is equal to 2. Again, make sure that you're showing evidence of your thinking, and you'll be held accountable for your work. I'm going to leave this here for just a moment because I know it might take you another second to finish up that equation solving. When you're ready to go, I'm going to turn the page over to what we're dealing with on medians. Our next topic is medians. We talked about medians in class on Wednesday. I do know that there's some 6-3, some things that we didn't finish up in our 6-3 notes on Wednesday in class, and every hour there was just a couple things that we didn't get to. We'll deal with those when I see you back again on Monday together in class. We'll finish up that 6-3 work. The medians of a triangle the medians go from the midpoint to the vertex of the opposite side. And then we're going to also have to remember that the medians intersect at the centroid. And the centroid splits the, I don't see a centroid here. The centroid would be in a place like there for number 3. And then even as we go further, we'll see all the medians drawn. But the medians split the sides into equal parts and go to the opposite side. There's no angle relationship. Some of these are pretty straightforward. If f to t, find f to e, the entire thing. If t to e is 8, well, if this has been split in half, that's just an angle marking there. The midpoint t splits it in half. If t to e is 8, so is this. So that would make f to e 16 when you put those two pieces together. So make sure you're reading about what it is that you have to find. And then once we start messing around with the centroids, I'm going to go down to number 10. The centroids had the 2/3 relationship. The 2/3 relationship where the centroid splits the medians into parts such that the longer part is 2/3 and the shorter part is 1/3. In the case of number 10, get yourself down to number 10. In the case of number 10, we're given that C to G, we need to find C to G, and we're told that K to G, the entire median, is 44.1. So if the entire median is 44.1 and we need to find the smaller part, K to C would be 2/3. We messed around with this in class yesterday. C to G would be the other 1/3 of the whole part. I don't have a calculator in front of me, so you're going to have to use your calculator to find out what 1/3 of 41.4 is. Had they asked us for K to C, the longer part, I would have done 2/3. 1/3 of 41.4. You can take 41.4 and divide it by 3. I'm going to move on to using some algebra. The 2/3 relationship. Let's see here. The 2/3 relationship is going to come into play. Here I think we're just dealing with, let's see, G to E and its midpoint, number 11. So this has to do with sides. And in number 12, we start getting more into, let's see, T to P. We're still dealing with just what's going on in sides here. Where was I at? It was number 14. Number 14, that was a challenge, and I wanted to show you how we would mess around with this problem, because now we're going across, we've got K to T, we're going across the median KB. KB is the median. That's the one that we need to focus on. And they give us K to T as this fractional part, 6x plus 6 all over 5. And then K to B, the whole thing, is this, 11/5 x minus 6/5. So with these fractions that we have going on, these algebraic fractions we have going on, I'm going to take you over to your line paper. And on our line paper, this was from the medians worksheet. And you'll have this work for number 14. On your line paper, we're on the medians worksheet, number 14. K to B was the entire, K to B was the entire length. What I know is that this longer part is 2/3 of that entire length. So using that idea, I'm going to say that 2/3 of the entire length, which is expressed as 11/5 x minus 6/5, 2/3 of the entire length is equal to the 6x plus 6 all over 5. Now, I think the best way for us to approach this problem out of the gate is to get rid of the denominators of 5. So we're not dealing with algebraic fractions. We've got a little bit simpler problem to do. And in order to get rid of or undo the denominators that are 5, what I'm going to do, and I'm putting brackets around just because of the parentheses here, I'm going to multiply both sides of this equation by 5. And what that's going to do is cancel out the denominator here. This 5 will cancel out this denominator and this one. So multiplying both sides by 5 is going to cancel out those denominators. And then I'm going to carefully look at what's remaining, 2/3. Now, 11x minus 6. 2/3 of 11x minus 6 is equal to 6x plus 5. So I'm undoing the divide by 5 on those fractions by multiplying by 5. And I haven't at all messed around with this 2/3 yet. That's my next move. I know if I multiply through this fraction by 2/3, I'm going to wind up with some wonky decimals. And so rather than multiplying both sides by 2/3, or dividing both sides by 2/3, I'm going to undo that by multiplying both sides by 3/2, the reciprocal. That's going to undo that there. And then I'll have 11x minus 6 equals 3/2. 3/2 is equal to 1 1/2 times 6x plus 5. And then I see us in a position we have a little bit easier equation to solve. I'm going to go through and distribute. And 1.5, let's see, 11x minus 6 equals 1.5 sixes is going to be 9x. And 1.5 times 5, this actually, wait a second, this is actually 6. Sorry about that. It was 6x plus 6. Good thing I didn't go too far yet. I caught it. 6x plus 6. So 9x plus 1.5 sixes is also going to be 9 here. When I go to undo, I'm going to take 9x's away from both sides. 2x minus 6 equals 9. I'm going to add 6 to both sides. 2x equals 15. I'm going to divide both sides by 2. I had worked this problem out on the other side of my paper. I'm going to divide both sides by 2 and be left with x is equal to 15. I'm sorry, 15 over 2, 7.5. So that is probably the most complex algebraic problem on the medians work. X is 7.5. Some of them are algebraic, but they're not as difficult or as complicated as that particular one was. Now, last but not least in this packet, we're going to deal with graphing. And I'm turning the page now to put your line paper aside for a moment. Finding the coordinates of the centroid. The centroid is exactly what we were dealing with. It's the point of concurrency of medians, where the medians come together. Point of concurrency from the medians. And so in each of these graphs, we're looking for the midpoints of sides. I'm quite comfortable with you just eyeballing and estimating where these are. I think a lot of them are pretty obvious. If you need to, remember the formula to find a midpoint, because that's where the median hits. The formula to find the midpoint is x1 plus x2 all over 2 and y1 plus y2 all over 2. So if you have to do any calculations, but I'm looking at number 1, and I can see what those medians are. And then from each of the medians, I'm going to sketch in from the median to the opposite vertex. And their point of concurrency is the centroid. So the answer to number 1 is going to be -2 and 1. Now, I don't think there's anything incredibly complicated on this. You'll just need rulers in your hand. And then you had graph paper from the beginning, because when you get to the back side, I expect that all of these are going to be graphed on graph paper. Think about a plan for where your origin sits. You know, look at the points that you have to graph before you draw your x and y axis on your graph paper, so you don't wind up with some big crazy graph that has all kinds of empty space. So think about where those are going to sit. You've got plenty of things to do to keep you busy for the rest of the hour on Thursday, and then you have all day on Friday. Again, if you don't have this done in class by the end of class on Friday, it will be marked late come Monday. Good luck.